Quotient rule.
What? Where is it? Let's write it down. I was batting at
So if f and g are differentiable, then d by dx of f at x over g at x is equal to, right? So now we're dealing with a quotient, right? So you're dividing. So you've got two functions. So it's g at x d by dx of f at x minus f at x d by dx g of x over g of x squared. So in other words, it's the function on the bottom, the g of x, times the derivative of the function on the top, so f prime at x, right? Another way to say that, minus the function on the top, f of x, times the derivative of the function on the bottom, right, g of x, there's a desk there, all over g of x squared, right? Just plain old g of x, just the function that was on the bottom. So we're doing two derivatives, right? And we're taking two times, we're just taking the original function. So if we look at this in prime notation, right? So in prime notation, then we would say f over g prime is equal to f g prime minus, g f prime, g f prime minus f g prime over g squared. Okay, so that one, might be a little bit easier to look at, right? So it's function on the bottom, take the function on the bottom, multiply it by the derivative of the function in the, that's called denominator, I guess. Take the function from the denominator, multiply it by the derivative of the function in the numerator, subtract from that the function in the numerator times the derivative of the function in the denominator, and put that over the denominator squared, right? You just square the denominator, basically. Right. Clean that up a bit. So that's the quotient rule. So let's try one. Right. Okay, so if y is equal to x squared plus x minus 2 over x cubed plus 6, then y prime is equal to, so we take the function in the denominator and put it in brackets, right? Everything's going to go in brackets. Even if it were a single thing, I'd probably just throw it in brackets just because. So it's g times f prime, which is 2x plus 1. Okay, there's g times f prime, minus f, there's f, the original numerator, times g prime, okay, so we're just taking the derivative of over g squared. Now don't actually square the g, right? Don't go, just leave it as g squared, right? We're never going to actually expand that out, okay? Because, you know, it could be something horrendous. You really don't want to, you know, we're not dealing with 12 terms here. So we just say over this thing squared. However, we do have to expand and simplify the numerator. So, how much detail would you like? Let's just do it. So okay, so I got 2x to the, and I'm gonna, when I multiply these out, I'm gonna do it so that I'm going in descending powers. Okay, so not necessarily the way that it, although actually, never mind. The way it goes, it will be descending powers if I just FOIL it. So 2x cubed. Whoops. Yeah, 2x to the 4th. That's why you're here, right? Plus x cubed. Plus 12x. Plus 6. Minus. All right, so I'm going to multiply each of these terms out, right? I'm going to get 3x to the 4th, so it's going to be minus 3x to the 4th. I'm going to get plus 3x cubed, so it'll be minus 3x cubed, right? Because of the minus in front here. Okay, I'm going to get minus 6x squared, but this minus is going to change it, so it'll be plus 6x squared. Over. And there's no shortcuts. You don't get to, I'm going to drop the denominator for 3 or 4 lines because I'm tired and I don't want to write all that stuff out. Right? Each line, you know, each, you know, this guy has to lead to this, or this has to be able to back up to that. Okay, they must be complete and full unto themselves. All right, so what do we get? So I've got a 2x to the 4th minus 3x to the 4th will be negative x to the 4th minus 2x cubed plus 6x squared plus 12x plus 6 over x cubed plus 6 squared. And that's it, right? What is that? Well, it's the slope of the tangent line to the original function at, you know, some point x. We choose a point x and we'll get the slope of the tangent line. So always remember, never forget, the derivative is the slope of the tangent line.
Is that the answer there?
Yeah, that's it. Yeah, we're just finding y prime. Yeah, I don't know. There weren't really any.
You don't have to take the x plus 6 and like
Square it? Oh, you should always do that. You remember me saying earlier? No, never expand the denominator. Best if you don't talk to each other while I'm talking. Okay. But we will never expand the denominator, right? You don't want to do that. You're going to get very complicated looking denominators. Yeah, we don't want to mess with them. So let's say that I had 3x squared. Okay, so I've given you a hammer. That hammer's name is the quotient rule. Every time you see a quotient, you don't have to use that hammer, right? Because you can look at this and just say, hey, I could use the quotient rule, but then I got this and derivatives and multiplying and squaring, and so, or I could just divide everything by x, right? So in this case, you should really just divide everything by x and then just use plain old power, right? Yeah, 6x minus x to the negative 3.5. Whatever, right? I'm not going to do this. But I'm just showing you don't always, just because we've learned the quotient rule, everything doesn't become a quotient rule, right? You say, oh, hey, this just simplifies. I should just simplify it. And then work it out from there. And, oh, wait a sec. Yeah, that was 4. 5. So I'll just do a couple more examples. So f of t is 2t over 2 plus root t. We want f prime of t. We don't give you the formula, right? We don't tell you what the product rule is. We don't tell you what the quotient rule is. You are expected to know this. Okay? So, yeah, we're going to be done in, I don't know, 10, 15 minutes tops. It's going to give you about an hour. You need to sit down and pound away for an hour. Like seriously, you're not going to, you go to university, you're going to be sitting at home pounding away for 2 or 3 hours doing assignments, right? If you actually choose to do any of the questions. And here you need to do lots, right? Do 20, 30 quotient rule problems, and you pretty much got a lock on the quotient rule, right? Watch me do it and say, that looks easy, and then test comes, you pretty much don't have a, But, you're all individuals, so some of you get away. You don't have to do a lick of homework, right? You can just sit, watch this, and do nothing, and score 95%. But, some of you can do a lot of work and score 60s. Life's not fair. Okay, so what do? We take... What do we take? We take G. Now, while we're at it, we're just going to change it, right? Instead of root 2, write it as t to the half, because we know we're going to have to do a G prime on it. Times f prime. Okay, so the denominator times the derivative of the numerator minus what's the thing up top? The numerator times the derivative of the denominator, right? So now I can look here as far as doing the derivative, right? I mean, I can look here, but I've written it, so it's sort of in a nicer form. And what will that be? 1/2 t to the negative 1/2, right? Over. Now, because I'm never going to expand the denominator, I'm not going to write it as t to the half, right? I'm just going to leave it as 2 plus, because eventually we're going to turn whatever expression we get up top, we're going to turn it back into a radical from an exponential, okay? So when we're done these, we generally want to see things in radical form. And seeing as we're not expanding this, then we can just leave it in radical form. Okay, so f prime of t, so we got what, 4 plus 2t to the half minus 1t to the half over 2 plus root t squared. Okay, so let's just take a look, make sure I didn't make any mistakes. We want this to be clean. Whoever happens to be looking at it. So what do we got? 4. Okay, 2t to the half minus 1t to the half is 1t to the half. But we're kind of done here, right? So that's going to be 1t to the half, which is just root t, over 2 plus root t squared. Okay, is that good? So, I mean, your job also is to say stuff like, where did that come from? Or, so just make sure that you have a handle on this, right? If you're looking at it, you're going, why is that root t? Okay, well, we got 2t to the half minus 1t to the half is 1t to the half, and t to the half is root t, and that's where that comes from. Any questions? Sorry, one more. Find an equation. I say find the equation. Find the equation of the tangent line to the given curve at the specified point. So it's sort of just a general instruction, right? So I'm going to give you a curve and a point, and maybe I could do like or this could be the instructions for like question 3, and then there's like A, B, C, D. But I'm not doing A, B, C, D. We're just doing the one. So curve is y equals x squared minus 1 over x squared plus x plus 1. And the point is 1, 0. Okay. Okay, so g f prime minus f g prime over g squared, expand, minus sign there, remove the bracket. Okay, I'm not going to remove the brackets on a separate line. I'm going to go along and just take note of these changing sign as I collect terms. So 2x cubed minus 2x cubed is 0x cubed. 2x squared minus x squared will be 1x squared. 2x minus negative 2x is 2x plus 2x, which is 4x. Minus negative 1, so that's plus 1. Over x squared plus x plus 1 squared. Okay, so what is that? That's the slope of the tangent line, right? What do we want? We want the slope of the tangent line when x is equal to 1. So what are we going to do? We're going to throw a 1 in there, right? So at the point 1, 0, what's the equation of the tangent line? So we need the slope of the tangent line when x equals 1. So when x equals 1, I have to do this over here. When x is equal to 1, y prime is equal to 1 squared plus 4 times 1 plus 1 over 1 plus 1 plus 1 squared. Okay, which is 1 plus 4 plus 1, which is 6 over 3 squared. Don't write that as a 6. Some of you would do that, right? It's like, look at the test and go, why did I do that? So it's 6 over 9, which is 2/3. Okay, and we should reduce, if we can, reduce fractions. So now we need a line with slope of 2/3 passing through 1, 0. So you then use your favorite way of finding the equation of a line. You don't know by now, this is my favorite way. So y minus 0 is 2/3 x minus 1. Y is equal to 2/3 x minus 2/3. So this part I'm just going to multiply everything by 3. 3y is 2x minus 2, and so 2x minus 3y minus 2 is 0, and there it is. The equation of the tangent line to the given curve at the point 1, 0. Okay, so I mean, what's the big deal? Well, all we're really doing is we got to find the point on the line, because I could have just said when x equals 1, you would have to do one more step. Right? I got to go to the original function y equals, put in x equals 1, and figure out what y is. Now I've got the point 1, 0. I have to find the derivative, y prime, that's the slope. I need the slope at that point, right, when x equals 1, which is 2/3, and I plug stuff in, and there's the equation of the line. Questions? Comments? Concerns?